Hello, welcome to the Requirements Elicitation, Planning, Analysis, and Collaboration Framework. My name is Perry McLeod. I'm a project management and business analysis professional with over 20 years experience in the field. I'm also an educator. I created this framework to help business analysts and project managers improve their project outcomes, increase value, and lower costs. For the next little while, we're going to take a journey through a visual overview of what REPAC is and how it can be useful. Today's framework is brought to you by the letter N, and N is for need. The entire framework is based around the concept of a need, separated from that of a requirement. The elements of REPAC are as follows: source, focus, perspective, depth, and assembly. Focus, perspective, and depth create something known as a REPAC collaboration set, which we will take a look at later on. First of all, let's try to understand what REPAC is and why I created it. I've centered the idea around a need. We know that a visual or some sort of written representation of a need is a requirement. But what do requirements look like? When I think about a requirement, I look beyond a visual representation, a schematic, a drawing, a design. I look beyond a use case, and I look beyond the simple texts that we find in a business requirements document, such as the system will have this or the system will have that. For me, a requirement is more like an atom. If you could split one open, what would it look like? What would you see inside? Think building blocks. Atoms are the basic building blocks of matter. Atoms are made up of even smaller things known as particles. Think about requirements as the building blocks of a solution for all things that matter to an organization. Requirements are made up of even smaller things known as elements, and we'll take a look at what those elements are a little bit later on. So together, for me, these elements create a closed, looped analysis superstructure consisting of interrelated and interdependent parts. We'll take a look at what those things are as we go through this overview. You'll see I've got a picture of Lego. When I think about Lego, I think about requirements. When I'm helping my son put together a Star Wars speeder or the Millennium Falcon, the instructions are the business requirements document, and each Lego piece is an individual requirement for that Millennium Falcon. Yes, I'm a Star Wars fan. So let's take a look at the very beginning of our REPAC framework. Now, in order for us to build a requirement, we need source material. And we typically get our source material from the wants, issues, needs, complaints, etc. from our stakeholders. Now, I've grouped these into two very basic areas: threats and opportunities. So the composite source structure is made up of a threat subsystem and an opportunity subsystem. And you can see roughly what they are. Of course, there would be more. This is just an introduction. In my mind, I would never say to a business analyst, go out and gather the requirements. I would never do that myself, and I wouldn't ask anyone else to do it, and I don't teach it. I believe that what you should be doing is going out and gathering or eliciting the wants, needs, issues, complaints, threats, opportunities, so on and so forth, from your stakeholders, and then building or assembling the requirement, which just happens to be part of this framework. And we'll go through how that actually gets done. So we take our source material and we transform that into needs. So our source material can be exceptions, issues, changes, errors, opinions, attitudes, change requests, anything that triggers the identification of a need. The source represents that initial information that provides energy to the system that drives us through our business analysis. So we identify the root source, issue, cause, or whatever brought us to the stakeholder. And then from the source, we ask what is needed to resolve the source. Then we ask ourselves what is required to fulfill the need. Now, it's a little bit of a twist on what we normally say. Rather than saying to our stakeholder, what are your requirements? We ask our stakeholder, what are your needs? And then we ask ourselves, as professionals, what is required to fulfill the need. For example, as a project manager, I might say, what is required to maintain quality in my project? Timely delivery of work products, full-time resources, experienced resources, adequate budget, so on and so forth. These are requirements for my project. Now you'll notice, I apologize, I misspelled analyze here and there throughout this presentation. And so these are graphic images, so I couldn't easily fix that. So I'm just apologizing ahead of time. So we have a need. So we've taken source material and we've done some root cause analysis, and we've asked ourselves what is needed to fulfill the problems that our stakeholders are bringing us. So now what we want to do is we want to analyze to identify what is required to fulfill the need. And this is our assembly superstructure, or composite requirement superstructure. When we're assembling a requirement, there are many things we must ask ourselves. Now we're going to go through each of these independently later on, but I just wanted to give you a quick introduction. We've got data, we've got descriptors for data, conditions, characteristics, value, rationale, fit criteria. None of these should be unfamiliar to you. In fact, all I'm doing is taking very recognizable ideas and grouping them in a way that you may not have seen before. And really, that's all REPAC is. I'm repacking requirements. I'm repacking the way we do our job. So basically, the Requirements Elicitation Planning, Analysis, and Collaboration Framework takes our source, puts it into focus, looks at it from a certain perspective, identifies the need, and then assembles all that information into a requirement. So let's go through the details. Focus. What are the different things that we can focus on? Well, we can focus on the environment, external business ecosystem, organization, culture, governance, policies, stakeholders, so on and so forth. Now, by focus, this is something that we would give our attention to. And by giving our attention, we are being slightly myopic, but that's what we want. What we want to do is, rather than having our thoughts go every which way, we want to focus our attention on something very specific. Now, the organization, for example, each one of these breaks out into more and more information, but we'll just take a look at a couple of them. So let's take a look at external business ecosystem and the organization. So the external business ecosystem breaks down into things like clients, customers, suppliers, general public, partners, competitors, regulators, governments, countries, municipalities, jurisdictions, that sort of thing. Now there's a relationship between all of these. Each of these, collectively and independently, will drive and constrain how the organization conducts its business. And so when we're looking at the focus and we're deciding what we want to focus on, we would ask ourselves, How are these bits of focus driving and constraining our organization in this matter, for this problem, for these needs? Now, you don't necessarily have to pick one of these, and this is the great thing about REPAC. These are permutable. So I could ask myself, how will I focus my attention on customers and clients, or customers and suppliers? So what I might do is ask myself how my customers and suppliers are related to this business problem collectively, and how they drive and constrain me to make a change in this instant. Now, I must support and sustain these items, these elements of REPAC, if I want to continue doing business, if I want to stay viable, if I want to stay competitive, if I want to remain compliant, and so on and so forth. So I have to understand these relationships. Now, if we take a look at individual elements within this layer of REPAC, there are relationships between each other as well. For example, competitors and regulators. Competitors have to support and sustain regulations, and regulations drive and constrain competitors, as well as us. And so we would have to understand those relationships as well, if it's germane to our problem. If it's not, then we would ignore it. Now let's take a look at the business architecture, which breaks down into guiding principles, vision, mission, strategy, objectives, goals, so on and so forth. And again, there would be a drive and constrain relationship, as well as a support and sustain. And this is a paradigm that you'll see throughout the entire REPAC model. So let's move on and take a look at perspective. Now, you'll notice I've got an image down there with two avatars. One is thinking 6 and the other is thinking 9. And what are they looking at? Well, it depends on their point of view. It depends on their perspective. And that's exactly what perspective is intended to be. So what is your perspective on the things that we are focusing on? How do you view the relationship between the organization and its competitors? What is your point of view? And that's exactly what perspective is. So perspective breaks into our organizational perspective, information, and technology. And you'll notice in the middle I've got choreography. And again, this is a concept that is persistent throughout the REPAC framework. All of these have to choreograph with each other. None of them can work in a silo. And this is how we build an architectural sense within the framework itself. So we'll take a look at each of them. So when we're taking a look at things like raw materials, business entities, services, processes, this is very much within the world of a business analyst. But you'll notice that there's a lot of other information that is not only around this particular set of concepts, but very much intermingled, intertwined with all this information as well, hence the term choreography. And there is a drive and constrain, support, and sustain relationship here as well. All right, let's take a look at our next one. Data, structure, integration, business applications, so on and so forth. Again, information that a business analyst or perhaps even a systems analyst might look at. In this point, for this framework, I make no distinction about titles or responsibility. Here we're talking about project teams, and different members within the team will be responsible for different things. And you would just decide who's responsible for what. All right, last, let's take a look at data technology, application technology. You'll notice this is very architecturally driven, and that's the idea, because we want that choreography, we want that interplay between all these different concepts. All right, let's take a look at depth. Our depth of perspective in this case is how deep do we want the analysis to go? We've decided what our focus is going to be on, one or two different elements. We've decided what perspective we're going to take on those elements, Now we have to decide how deep we want our analysis to go. Our complexity of analysis brings dimension to perspective and focus, allowing for several layers for analysis. This is what our depth looks like. So depth takes on three different concepts: type, form, and aspect. There are two different types of depth. There's context and concept. Depth will take on two different forms: behavior or structure. And there are two different aspects to depth: logical and physical. So when you're doing a depth analysis, you build your depth model using these three ingredients. You would decide to do a contextual analysis that is focused on behavior, that looks at the physicality of something. Or you could have a contextual analysis that is focused on structure, that looks at how something is logically assembled. Now, let's take a look at what those mean. Context versus concept. When we think about context, we're thinking about words such as fixed, archetype, established, paradigms. These are patterns that are indicative of all things, regardless. For example, driving an automobile. It doesn't matter where you are, but more or less, it's the same. To go fast, you push the long pedal on the right, and to stop, you push the short, fat pedal on the left. Well, sometimes this changes from vehicle to vehicle, but again, this is a contextual way of thinking. These are contextual designs. So when you're doing an analysis, the first thing you would ask yourself, well, let's take a look at the context and let's understand how it's done regardless. For example, applying for a loan. It doesn't really matter where you go. It doesn't really matter what century you're in. Applying for a loan is about the same now as it was 2,000 years ago when we first decided to lend money. The idea has obviously become more complex over the years, but from a contextual perspective, it's more or less the same. Now, when we look at the concept, we're looking at something that's more relative, something that is informed, something that is specific to our needs. Think of it as an instance of the context. So, contextually speaking, this is how loans are applied for regardless. But in our institution, for our customers, for the way we want to lend money, this is how we are going to do it. And that's where you get into a conceptual analysis, and it's becoming more specific. So context illustrates pattern-based thinking. Elements identified in context are used to inform the scope itself. Conceptual analysis is specific to the scope. So, as I said, it's an instance of the context. So we identify the pattern, and then we ask ourselves, how are we going to implement this pattern for us to solve this problem at this time? And that is the difference between context and concept. So really, you need to be starting with a contextual analysis almost all the time. And then once you've identified these hierarchical patterns, these paradigms, you can then ask yourself, well, how does that apply to me? How does that apply to this organization? How does that apply to these problems at this moment? And once you've identified that, you may now start to look at the individual behaviors and the structures of how it's put together. And after that, you may then start to ask yourself, well, regardless of what solution we build or purchase or improve upon within our own organization, how must it work? What logical connections must take place? What policies must be present? What rules must be there? What operational processes must we build, regardless of what solution we build or buy or whatever? And then once you make those choices, you can then ask yourself, now that we've decided what we're going to do, how are we going to do it? And that's your difference between the logical and the physical. Logical is solution independent, and physical is solution dependent. And that is the final part of depth, that's your aspect. So understanding your depth of analysis in this way is very, very important for the REPAC framework. All right, let's move on and let's actually take a look at the assembly. This is where things get a little bit complicated. Now, there's a lot of fancy words I've got here: composite requirement structure, composite quanta substructure, blah, blah, blah. And I realize that they're a little on the complicated side, probably something I'm going to change later on and make them simpler. When I was building this, I wanted to do it from an architectural perspective, and my inspiration actually was quantum physics. So I was probably a little more technical than I needed to be. So anyway, let's take a look at this. How does this break down? Well, when we want to assemble our requirement, remember what we've done so far. We've taken some issues, complaints, problems, a change request. Something has come to us. It could be a threat to the organization. It might be an opportunity of some sort. As good business analysts, project managers, and project teams, we should always be trying to turn our threats into opportunities whenever possible, or creating opportunities from our threats. So this information came to us, and we chose what we wanted to focus our attention on. And we could choose 1, 2, 3, maybe 4 different things from our focus list to build a focus set, a focal set, if you will. We then decided what perspective we want from that particular set of focal points. And then we decided how deep we want to go in our analysis. Now what we're going to do is go through a bit of a process here to actually assemble the requirement. And so we're going to identify what the rationale is, why are we doing this, and our fit criterion. How will we know that once we do it, it was the right thing to do? So this is asking those 2 very basic questions. Are we building the right thing, and are we building it right? We have to identify that the need matches value for the organization. Again, nothing new. The IIBA has been teaching us this for years. Does that identified need match value for the organization? If so, let's proceed and identify what it must do, what actions it will take, and what responses there will be. Now remember, we are not stating a requirement, we are assembling a requirement from some complaint, some issue, some information that was given to us from a stakeholder, the source data. So we're building something of value. Now, I'm just looking at a particular instance of a requirement, but imagine that as you go through this, your wants, your needs, and so forth are going to turn into many, 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 many requirements. So you're going to be taking this process for each idea, each concept. Then we're going to take a look at things like conditions and characteristics, your non-functional requirements, if you will. So now we have something called a stated requirement in a traditional or classic sense. We have something that we can work with. So we've identified what it is, why it is, we've identified a way to test it, we've identified what it must do, the steps that it will go through, and the responses that will be given to it as it goes through its steps, which is why I call it a force pair relationship. We can now test it. And so now we're going to go through the testing part of the assembly. So the top part is the actual assembly of the requirement, if you will. And then the bottom part is testing what we've done to make sure that it is correct. So now we're going to go back to our identified value, and we're going to make sure that what we've built so far still matches the value and still matches the need. We are then going to look at our rationale and our fit criterion, and again, verify that what we did at the top part the data, the descriptors, the conditions, the characteristics, the behaviors, the actions, the responses. We are making sure that all of that still matches value and still meets the identified need. And once we've done that, we now have classically what we would refer to as a verified and validated requirement. It's possible that it would have to go through change, and if so, it would go into an entire change subsystem, which is not covered here. That's just part of your regular change management. But again, you would have to take parts of REPAC and incorporate that into the change management subsystem where appropriate. And then all the way back to the beginning to verify, again, that what we put into the assembly process is what we get out of it. And so we want to have a close to one-to-one ratio as possible. Anything that deviates from that obviously is going to affect our quality. So really what we're doing here is we're taking raw material, threats, opportunities, wants, needs, problems, etc., and we're putting it through a requirements assembly machine. And what do we get out of that is a requirement that has been built using behaviors, actions, responses, conditions, characteristics, so on and so forth. We do not, at least the REPAC framework, does not distinguish between reporting requirements or functional requirements or non-functional requirements or Bob's requirements or any other type of requirement for that matter. A requirement is a requirement is a requirement. And we use the data and the descriptors to distinguish one requirement from another. So if you want to call it a reporting requirement, that's fine. That's just a descriptor to describe the requirement that you've built. And the entire thing repeats itself. Now, let's take a look at each of these individually. So our control subsystem and our feedback subsystem. So we took the source and we built raw materials. And remember, exceptions, issues, complaints, threats, so on and so on and so on. And we put that through our requirements engine. Our rationale is the reasoning that supports the need. The reasoning must obey rules of logic. So it's got to make sense, obviously. Rationale drives and constrains the requirement. Source and rationale are supportive of each other. Source and rationale drive and constrain the system as a whole. The identified need is simply what the business analyst has, through careful examination, identified as the true need, as opposed to a want or a desire or some sort of band-aid. So there's been root cause analysis. We know exactly what this is, and now we're going to put it through our requirements engine, or our assembly plant, if you will, and we're going to structure a requirement. We're going to build one. Just like you would an atom or a molecule. You're going to assemble it bit by bit. So it's more than just a single line in some sort of business requirements document. It's more than just the system will. Value. The system must deliver value to the stakeholder and the organization. And we measure value in two ways: extrinsic value and intrinsic value. Extrinsic value, the benefits of a thing associated through external agency. Intrinsic value, belonging to a thing by its very nature. So extrinsic value is a means to an end. The extrinsic value of A can be traced to the extrinsic value of D through B and C. Money has extrinsic value because you can buy garments to cover yourself. Those garments in turn have extrinsic value because they protect you from the elements. And while they're protecting you, they offer social acceptance because you're wearing cool colors, cool designs, you're wearing what's trendy. It allows you to be accepted into a subculture. You can be a goth, whatever the case may be. So there's extrinsic value there. What's intrinsic value? Well, this is a little more fuzzy. It's a philosophic property. It's the belief that a thing can have value in of itself. So it's a belief system that the underlying perception of true value is based on the sum of all other value-add considerations. So as an economic principle, intrinsic theory of value or objective value is an axiomatic approach. So it suggests that the cost of producing the thing, whatever it is that we're producing, once built into the product, cannot be removed. And so it has intrinsic value. Think about baking a cake, for example. So the basic ingredients for a cake is flour, eggs, water, sugar, so forth. Once those things are combined and baked, the cake takes on, or those products take on something different. They're not eggs anymore. They're not wheat. It's not sugar. It's a combination of things creating something new that didn't exist before. And so it now has intrinsic value. And so the cost of creating that thing become part of that thing itself. And so how does this fit into the REPAC framework? Well, we must ask ourselves, what is the value of what we're producing? Once we actually assemble the thing, can the cost of what it is that we assembled be separated and measured? These are things that a business analyst might have to ask himself or herself. Oh, that's not showing up too well. To create an identified need, we elicit the raw information from the stakeholder along with the rationale and the fit criterion and the intrinsic or extrinsic value. So we don't ask our stakeholder, what's your intrinsic value here? We have to ask, what value is it going to serve? What is its purpose? And our job is to identify its bits and pieces, so the actual intrinsic value that will make it up. So somebody says to you what the value is, and it's your job as a business analyst to identify all those little bits and pieces that will make up the overall value that will eventually become embedded within the requirement itself. So let's take a look at our assembly on the behavior side. So behavior, all requirements have to do something. Now, you're going to see this a little bit later on, but when I was building the REPAC framework, I thought to myself, every single requirement has to have common elements, regardless of it, whether it's reporting or data, whether it's a specification, any kind of category or any way you want to organize that requirement. They all have to have the same elements. And that was my sort of atomic approach to this whole thing. What are those constituent elements that are the same for all requirements? And so that's what I've narrowed this down to. So our behavior. So in my mind, all requirements, regardless, must do something. So a report, what is the report doing? It's informing. Who is it informing? Why is it informing them? What decisions will they make? So on and so forth. So this defines a range of actions in combination with itself and its environment. It is the response of the system or an organism to various stimuli. And by organism in this case, I mean a user, for example. Whether it's internal or external, conscious or subconscious, overt or covert. This is basically from Wikipedia. And that's how Wikipedia defines behavior. So the behavior is going to constrain and drive all the elements within the structure, and we'll see what those different elements are. When we actually look at the anatomy of a requirement, you'll see what those are. So when we talk about action and reaction, this is just classical Newtonian physics. With every action, there's an opposite equal reaction. So when we're going through our behavior, there are certain steps or actions that the behavior will do. And there has to be some sort of reaction to those steps. If this sounds familiar, if this sounds like a business process, well, basically, yes, that's what we're talking about here. We're talking about the overall process, which is the behavior, and then the individual actions or steps within that behavior, and the responses from both people and computers, responses from rules, responses from policies, and so on and so forth. We have to identify what all those responses are. Remember, the fit criterion is the standard by which something can be judged or measured or decided. So fit to purpose would be an example. When we're looking at projects and we ask ourselves, under what conditions will our stakeholders accept this project? Same idea here. Under what conditions will our stakeholder accept this particular requirement or behavior? So behavioral relationships. Each need drives and constrains one or more behaviors. Each behavior supports and sustains one or more need. Each behavior drives and constrains one or more actions. Each action supports and sustains one or more behaviors. Each action drives and constrains a response. And each response supports and sustains one or more actions. So basically it's behavior, action, response. Behavior, action, response, and so on and so forth until we end the cycle. For each need, there will be at least one behavior. For each behavior, there will be one or more actions required to fulfill that behavior. For each action, there will be one or more responses. And a response may be from a human to another human, or it may be from a human to a machine, thus creating a system. And this is what that requirement looks like from its atomic point of view. So remember, we decided what we wanted to focus our attention on. And then we decided what perspective we want to take on that focus. Is it information-based, technology-based, user-based, so on and so forth? Then we decide how deep we want our focus and perspective to go. Are we taking a conceptual view, so an instance of a pattern, and then trying to see how that pattern applies to us at this point in time for this problem? Are we focused on the behaviors themselves, or are we focused on the structure? Are we looking at it logically? So is it a solution-independent depth of analysis? Or is it solution-dependent? Are we actually trying to identify where things will go? And once we figure all that stuff out, we can now actually start to assemble our requirement. And so our behavior has with it data. Data has descriptors, so data about data, metadata. Remember, data is data. Data means nothing until it's given context, and then it's called information. So once it actually can have some value to somebody, we don't call it data anymore, we call it information. So that behavior, as I mentioned, will have one or more characteristics. Those characteristics can be events or components of the behavior. The behavior will also have conditions. They will be event-based or component-based. And then the behavior has actions and responses. And those actions and responses will either be normal or exceptions. If this kind of looks familiar, it should. These are all the things that we should be doing as business analysts. All I've done, as I said, is just put it together in a way that I hope makes sense and helps business analysts and teams decide what's important, what's not, what conversations are worth having and which ones aren't, where to go looking for the information, and how to go looking for that information. Along with the identified need, focus, perspective, and depth, when they come together with the source material, rationale, fit criterion, and value, all come together to identify all the elements that are surrounding that desired behavior. And this is how we assemble a requirement from an atomic level. So we're not merely just writing the system will allow the user to blah, the system will allow the user to so on and so forth, and hopefully maybe capture all this stuff, but it would be spread around the document. It would be very difficult to understand as groupings of information that belong together. And so this is what you're doing. You're grouping information that belongs together. This atom, that atom, this atom, that atom, together creates a molecule. These molecules together create something of substance and value. And so we're reorganizing the way we actually capture this information. All right, so let's take a look at how we do this. So we identify conditions, characteristics, data, and so forth. Data, the individual facts that must be stored against the behaviors, actions, and responses. Data descriptors, information stored about the data itself, who created it, when it was created, and so on and so forth. Characteristics, distinctive non-functional qualities and states possessed by the behavior and other elements within the system. And then conditions, distinctive imperatives that the system must follow as a matter of structure or process. So think about this. You're making a dinner, and you have children in this scenario, and your kids are bugging you, and they want your time, and they want your energy, but you're busy, you're distracted, and you need time to focus on what you're doing, or mistakes will be made. So you say to your children, well, okay, you can go do this, or you can go do that. And so you're specifying a behavior. You can go outside and play, or you can play with your iPad, or you can put together a puzzle, read a book. But then you give conditions under the conditions under which they can do these things. So you can play with your iPad, but only for 10 minutes. You can go outside, but you have to wear your winter coat. You can read a book, but you can't read that book, only this book. And you can only read it for 10 minutes, and you can only read these chapters. Not to say that those are reasonable rules, but the point is, every behavior must have rules. And so for every requirement, we have to specify what those rules are. Now, we know that we have to centrally store things, and so we're not going to specify those rules right beside the behavior. We're going to reference the rules in a central repository and then reference which rules get which behaviors and which behaviors get which rules. Now, this is very difficult to do if you only have Microsoft Word or a spreadsheet, which is why the requirements, the requirements framework here, REPAC, actually works quite well within some sort of requirements management system. You could even design a system around it if you wanted to. Now, the quanta subsystem. So in physics, a quantum is the smallest amount of something. And so in our analysis superstructure, we use the idea of quanta to account for discrete characteristics or states that the behavior will or will not be in, depending on how those conditions are or are not met. If this sounds like a use case, then you're not far off. That's basically the idea here is not that far off from a use case, except we have the ability to capture it in ways other than a use case. So we're taking those ideas and pulling them out, and we can capture them in spreadsheets or traditional business requirements documents if we don't have access to use case or if our environment does not use use cases. We are starting to transform an identified need by identifying the discrete quanta needed to realize it, along with the behavioral elements. So we are, in effect, constructing a requirement from the ground up, and all the elements that are necessary to realize the requirement get attached to it and come along with it. So a condition is a material implication or consequence. A condition must support behavior. The condition drives and constrains actions and responses. The substructure for a condition looks like this. So let's start with the top part of a condition, and that would be a policy. So policies must have endorsements. So somebody out there must say, yes, I endorse this policy and all the conditions that will be made from it. The policies will either be internal or external. If they're internal, we are allowing them to drive and constrain ourselves. If they are external, then we are creating internal policies from the external source. So there's a support and sustain and drive and constrain relationship there as well. Now, policies are the basis for what I call business rule statements or groupings of business rules. And these can relate to each other. So business rule statements are grouped together with other business rule statements. And inside them, we actually have individual business rules, which are conditions. Those conditions will either be operative or process-oriented or structural. An example would be, if it's a process, it would be things that the business has decided as a matter of course or as a matter of doing business because of the policy. We're going to do this, we're not going to do that, we're going to do it this way, we're not going to do it that way. But structural rules are rules that are derived through the building of the system itself and are fairly immutable. So they're typically designed right into the system. It could be a derived value, it could be a calculation of some sort. So these are rules that actually are required to create structure. For example, a one-to-many relationship is an example of a structural rule. And you can see the drive and constrain relationship here as well. So operative rules or operative conditions will drive and constrain the structure, and the structure must support the operative rules. And it must be built that way, and the requirement must reflect that. Okay, so now that we know how this whole process works, let's go through a review. So, what did we learn? We were made aware of an issue, or some such thing. Through careful research, we identified a rationale driving the issue. And that helped us transform the source material, whatever it was that got us started, into a stated need. And we know that it's a stated need because it accurately reflects what the business requires, and it's testable. We have a fit criterion. Next, after we've identified the fit criterion or standard by which it can be judged, we're now ready to transform it through value into that requirement that we're going to build. We've also learned that we must look at a need in terms of focus, perspective, and depth. We decide what we want to focus our attention on, what our perspective on that focus will be, and how deep we want the analysis to go. Do we want a high-level analysis at the contextual layer or a very deep analysis at the physical layer? Will it be behavior-driven or structurally driven? Once the need has been identified, the analysis journey begins. So we find our anchor, that's our focus. Next, we provide some perspective to that focal point, and then finally we choose how deep the analysis will go. And we start to assemble our requirement. Along with the identified need, focus, perspective, and depth, they all come together with that source material rationale, fit criterion, and the value to identify all those elements that are surrounding the desired behavior. So it all fits together from the behavior. So the need and the behavior have a very, very close relationship. Once we've identified the need, we would ask ourselves, what behavior is required to fulfill that need? And then what are all the other things that surround that behavior? All the different electrons. What is the characteristics, the conditions, the actions, the responses, the data, the descriptors, all those things that surround the behavior? What are they? And we would have to identify those. And once we've done that, we have built a requirement at the atomic level. Using the focus, perspective, and depth, we've analyzed an identified need to determine which elements of that quanta substructure need to be specified and modeled. Now that we've done all that, we've tested it, we can now start to write it out. Once all the requirements have elements, once all the elements have been identified, whoops, looks like I made an error there, and we've gone through some sort of logical test. If it passes the test, we can then continue to build or assemble the requirement as a specified document or as a diagram or as part of a database or whatever means that is at our disposal. If our logical test has failed, then we have to start the process over again. So this is done for every need, every want, every desire, everything. If you take a look at the bottom left-hand corner, you'll see an example of how one might write out all of this information in a classical BRD. And so basically all the different elements of that atomic requirement are surrounded by a table. It would be best to do this in a spreadsheet at the very minimum, so at least you have some sort of a flat file that you can filter and pivot table and all that kind of stuff. But you can certainly do this in a business requirements document. So what REPAC is doing for you is it's helping you identify what information you want to talk about at a meeting. It's helping you identify what information you want to plan out for a work product. It's helping you identify what things you need to analyze, what conversations you need to have, what workshops you have to have, what interviews you have to have, what questions you will ask, how deep those questions will go, and how you would organize that information and put it into some sort of requirements repository afterwards. So in summary, each subject within the focus and perspective domains are permutable. These permutations allow the BA and project team to build thousands of different planning, analysis, or discovery events. Along with the 8 different depth choices, the project team and the BA may continue to explore the subject from the highest contextual level to the deepest physical level, all without even considering a solution. This is what I call the REPAC set. Now imagine, if you will, that you've got a deck of cards. I don't know specifically how many, but you've got a deck of cards, and these cards are divided into focus, perspective, and depth. And you look through the focal bits of the focal cards, and you see the different elements that we talked about at the beginning of the presentation, and you pick out which ones you want to focus your attention on, and that becomes your focal set. And then you look at perspective, and you pick out what you want to talk about at perspective, and that becomes the perspective of the focal set. Then you decide how deep that conversation is going to go, and that's the depth of your focal perspective set. Together, that is your REPAC collaboration set. Now you have dealt yourself a conversation. You've dealt yourself a means to analyze something, to elicit that raw material for a need, to conduct an interview. It's your objective now. To have a workshop. You now have an agenda for your workshop. You now have a means to interact with a client or user or whomever at a very, very specific way. You can literally lay the cards out in front of them and say, this is what we're going to talk about, and only this. And the next time we engage, we'll talk about this other stuff over here. But it helps us to stay focused, literally stay focused, because we have our focal set. So imagine on these cards, on one side, you've got what the card is and what part of focus it is. And then on the other side, you've got a description of what that is. And so you put that together, and now you have a very, very clear understanding of what it is you're doing, with whom you're doing it with, or with whom you're doing it, and why you're doing it. So REPAC can really help you as a business analyst and as a project team to plan and elicit and collaborate and analyze information. So building that permuted focus and perspective sets and analyzing this information at various depths helps you to create different instances of your planning packages or different instances of your workshops and your interviews and so forth. This allows for a very repeatable, very measurable process, because now you can take this collaboration set that you dealt yourself and say, okay, this is what we're talking about. Now let's go do it. And now you can track the results of that and say, okay, we used these cards and this is what we got. Now let's use these cards and go see what we get. And you keep going through the deck until you've covered all the things you need to cover. So you basically play requirements in a way. And that's pretty much it. There is a lot more to cover, but this is just an introduction. If you're interested to know more, this is how you can contact me. You may tweet me, I guess that's the expression, at BSAP McLeod. LinkedIn, just Google my name, Perry, P-E-R-R-Y, McLeod, M-C-L-E-O-D. You'll see me at the top of the Google hit. Connect to me through LinkedIn, ask any questions you like. SlideShare, Tumblr, so on. I don't really use Tumblr. My email. You're viewing this right now on YouTube, and I hope it was of value. I'd be very interested to know what you think. It's my hope someday to actually publish this as a book and create the cards that I mentioned for you and actually allow you to deal yourself success. So thank you very much for your time, and I hope you found this of value.